Okay, Assalamualaikum. Today I will explain about the exercise one in the independent. Okay, as you can see, I have uh, I have key in the data group and BMI. So I will go to find normality of this group. So we go to analyze. We will go to the descriptive statistic and we go to the explore. So as you can see here, the dependent list I put BMI and the factor list groups. Okay, before we click the OK button, we need to go to the plots. Okay, in the descriptive, we need to click histogram. And we also need to click normality plots with dash. So I will continue and I will click OK. Okay, next we will go to the graph. Okay, we will go direct to the test of normality because we want to find the normality, right? So we'll direct go to Shapiro wheel and we'll go see significant because as you all know, if point is more than 0.05, it will be normal. But if it low than 0.05, it will be not normal. So based on the significant, for athletes it's 0.092, which means it is more than 0.05. So athletes is normal. Then the non-athlete is 0.601, which is more than 0.05. So non-athlete also normal. So we can see both of normality is normal. So we'll go back to the table. Okay, now we want to analyze the independence test. So when we want to analyze the independence test, we go to analyze, we go compare means, we go to independent sample test. Okay, like usual, you need to, the test variable will be BMI and the group variable will be groups. But we have two groups, we need to define group. Group 1 is 1, group 2 is 2. So click continue, click OK. So here will come up the independent sample test. Okay, we first look at the significant. If significant is more than 0.05, we will take the top row. But if it lower than 0.05, we will take below the top. So next we go to significant to tail. As we can see, significant to tail is 0.000, which means p-value is 0.000. This show that p-value is less than 0.05. So there is significant different. Okay, next we'll go to the exercise 2. Okay, for exercise 2 for independent, it's same as exercise 1. We have key in data. We will want to find the normality. So we go to analyze, we go to descriptive statistic, and we go to the export. Same, total energy expenditure and group. We go to plots, descriptive, histogram, and normality plots with test. Don't forget to click it. We'll continue and we click OK. So, okay. Okay, so we directly go to the test of normality. So as we can see, the significant for lean is 0.48, which is less than 0.05. And for obese is more than 0.05, which is 0.143. So we can see here, lean is not normal and obese is normal. So since the data is not normal, we need to use man with knee test. Okay, we will go back to the table. We go to the analyze. We go to non-parametric test, and we go to the legacy dialog, and we will go to the independent. Okay. Okay. Same as before, we have to key the test variable and group variable. Don't forget, group variable, we have two group. We need to define the group. group 1 S1, group 2 S2. We continue. And the important part is don't forget to click Man Whitney U test. Okay, so we click OK. Okay, so now the graph have popped up. So we want to know the so we want to know the value. We want to know the p-value. We'll go to the significant here. Assumption significant to 10. We show that 0.02. This show that p-value is 0.02. So p-value is less than 0.05. So there is a significant changes, different. Okay, hi. We proceed to exercise 3, which is dependent. Okay, first we need to find the difference. After we key in the data, we need to find the difference between pre and post. So we just click transform. We click computer variable. Okay, next we type different div. Div is more easy because simple. So we just key in the data post menstrual divided by premenstrual. Then you just click OK. Okay, after you have clicked OK, then the result will appear at the different in the table. Okay, next we will find the normality. Okay, we go to analyze. We go to descriptive statistic. We go to explore. Okay, in the dependent variable, we will put the different, and in factor list, we will not put anything because it involved in one group. So make sure click plot, we click histogram, and we click normality plots with test. So we continue, and then we press OK. Okay, then we directly go to test of normality because we want to know whether it's normal or not. So the significant is 0.490. It is more than 0.05, so it is normal. Okay, next, after we have know that it is normal, we analyze the pair. Compare mean. Okay, we go to pair simple t-test. At first we do independent, we will go to independent sample t-test. Now we do dependent, we will go to pair sample t-test. We click pair sample t-test. Okay. So the first variable will be the pre-menstrual and the second variable will be post-menstrual. Okay, after we have key in the variable, we click OK. Okay, and then there will be data here will pop up. Okay, so we will want to know the significance of two-tail. So as we can see here, the significance of two-tail is 0.000. So the p-value is 0.000. That means p-value is low than 0.05. So based on this table, we can know that there is a significant figure in this graph. There is a significant difference in this graph. Okay, next, we will proceed to the exercise number 4. Okay, it's similar to exercise number 3. First, we want to find the difference. We click transform. We go to computer variable. We target variable, we put different. And the numeric expression, we put post BMI minus by pre BMI. So after we then key in the information, we will click the OK button. Okay, after we click the OK button, we will click analyze, we will click the descriptive statistic, and we will go to explore because we want to find the normality. Okay, it's same than like previous. The dependent list will be the different, and the factor list will be none because there is only involved in one group. So don't forget to click plots, to click histogram, and normality plot with test. So before we click continue, I have to play this. Oh my god. Okay. Okay. Continue. Then okay. Sorry for the interruption. Okay, we already go to the test of normality. So the significance is 0.061. So as we all know, if the number is more than 0.05, it will call normal. Okay, after we have done identify the normality, we will go to analyze. Compare means we will pair simple t-test. As usual, variable 1 and variable 2, variable 1 is pre-BMI and variable 2 is post-BMI. Then we click OK. Okay, next, we directly go to the pair simple test. Okay, as we can see, the significant tail is 0.000, same as before. So from this pair simple test, we'll know that the p-value is 0.000. So this means the value of p is less than 0.05. So this table show that there is a significant difference. Thank you.